Well, hello everyone, and welcome back to yet another AWS OnAir Data Dive. This is the show where we dive deep and get those relational database treasures for you. I'm Aditya Saman, coming to you live from Dallas, Texas, where the temperatures are starting to drop, and of course, Halloween is around the corner. Now, speaking of things that are spooky, of course, a lot of us are database people here. We all worry about databases staying up. Some of you customers out there also have multi-region databases, multi-region application stacks. And coincidentally, that is the topic of discussion today. As you all know, we talk in detail about relational databases here. And today we're going to talk about Aurora Global Database. What it is, what problems it solves, how it helps our customers, and more importantly, how easy it is to get this database in multi-region up and running. So, as always, to talk about this, we've got some real strong SMEs in this area. You all know Cheyenne. He's a regular on our show. So we're going to get to you, Cheyenne, in a second. But we also have Rohan, who is a product manager of global databases. So, anything he says goes. So let's start with you, Rohan. Let's get those intros out of the way and let's get started.
Sure. Thanks, Aditya. I hope you can hear me. Raise
Yes.
your hand if you can. Great. Really excited to speak to all of you guys. I'm speaking to you from Seattle. I am a principal product manager on Amazon Aurora, and I look into a few of the features, especially focusing on high availability and disaster recovery. And I'm really excited to talk to you about global databases today.
Excellent. Well, welcome, Rohan, to the show. Hopefully, this would be, a continuing affair. Cheyenne, nobody needs your intros. Everybody knows you already, but let's do it anyway.
You're too kind. Let me just say that. Thank you, Aditya, for the kind words.
Of course.
Hi, everyone. I'm Shayan, and welcome back. Thanks for dialing in. So today we have a pretty jam-packed agenda. This is a little different from what we've been doing on the GenAI side. This is more relevant for operational best practices, and we're going to dive really deep into the global databases topic. So I work as in the same role, in fact, as Aditya. I'm a principal database specialist. I focus primarily on the RDS and Aurora engines. And thank you for dialing in. I'm sitting here in cold, although sunny, New York this morning. So thanks for joining in, and let's dive right in.
Excellent. Well, thank you for joining us, Cheyenne. And over the period of time, if you remember, Cheyenne used to be an acquaintance, and now he is a really, really good friend of mine, Ron. We hope to be a friend of the show as well. All right, Cheyenne. So let's kind of maybe start with the problem, right? A lot of our customers have these multi-region application stacks, and we kind of talk about our global databases for that as a solution to these application stacks. So can you kind of help us understand what potential problems do customers face when they have these multi-region application stacks, and how can a global database or Aurora Global Database help solve these?
Yeah, absolutely right. So I think starting off with the problem itself, it's usually very relevant, very unfortunate, but for those who are impacted in Florida, hurricanes like Helene and Milton, these natural disasters could actually wipe out your data centers completely before you realize it, right? So once they do this damage, it could be like power outages for prolonged periods of time, flooding, there's physical destruction of infrastructure. And this can actually destroy your hardware. This can lead to significant amounts of downtime, which actually translates for businesses directly to significant revenue loss, right? Because critical operations are interrupted, customer services are interrupted, there's recovery costs, there's a lot of things that go wrong. And typically, without these effective disaster recovery or backup solutions, data loss is another thing that could occur. And this compounds the financial impact, this damages the company's reputation. A lot of these things go wrong, right? So we'll talk about a couple of ways in today's episode on how we can deal with that. The other thing is, of course, the other problem that we were trying to solve with global database was everyone wants to expand their business, right? Everyone wants to grow internationally. They want to sort of grow their either their e-commerce website or their travel company globally. And so the other challenge was for these globally distributed applications, there is a need to serve these users who are global in different geographic locations around the world with minimal delay. They want sub-second response times. They want very quick sort of returns on their, let's say if I'm trying to book a travel ticket, I don't want to wait there forever. I want to get done with it and move on. So this ensures that users, regardless of their location, can very quickly access the data that they're looking for in their local region, leading to improved application performance and user experience at the end of the day. So we'll also talk about how we can do this with global database today.
Excellent. So I think you touched upon a couple of themes, right? Just ability to get the data quickly in remote locations or different regions, and also to kind of recover from failures quickly, even if there's like an entire region outage. And I think that is kind of our design principles here at AWS too, is like everything fails at all times. And even if we build these regions very resiliently, and a region is essentially a grouping of hundreds and hundreds of data center potentially, we are still want to build something that can sustain those failures. So that's great. But I'll tell you, I used to be a DBA a long time ago, and I remember doing anything that had any sort of fault tolerance or disaster recovery in region or in data center itself was not a straightforward operation, let alone going to another region, right? I remember having to talk to like data center operators and then get kind of a rack in one of their cages. Like, it requires a ton of work. I'm hoping that we don't have to do any of this with global databases. How easy is it to create a global database with Aurora?
Yes, I think very relevant. And gone are those days, right? So I relate to that very well because I used to be a DBA for the longest time. And there is there's so much planning required. There's upfront planning around hardware. There's upfront planning required around infrastructure, data centers, cooling, because these servers get like heated up very quickly. There's a lot that goes into the planning. And right, so typically, once you do that, you're actually stuck with whatever, right? And whatever capacity you purchase, whatever physical hardware that you get. And the challenge is to replace that or to scale up, scale down. It's just not worth the effort anymore, right? So I would get frustrated. I would not even look at like planning capacity. So gone are those days. With the cloud, it's like now super simple. And in fact, if you allow me to share my screen, I'm going to show you how quickly and easily we can actually create this, right? So
yes, we want to see those demos, man. Absolutely. Let's go for it.
There we go. So here we are. We have the RDS Database Console. And for folks who are actually not familiar with this, it's very easy. Once you get access to your AWS console, there's a search bar on the top. All you do is type RDS. And you select this, you go to your databases screen, and then I have a bunch of databases, out of which this is the one that I'll be using today. So this is very aptly named, right? So no pun intended. But you'll see that this is a regional cluster. And within the Aurora, if you're not familiar with Aurora, Amazon Aurora, it is our relational cloud native purpose-built database. And it is compatible with two of the most popular open source engines, MySQL and Postgres. So I right now have a Postgres deployment. You can very well do this with MySQL. And global database is actually just a feature that builds on the best things, the best practices around Aurora, right? So we'll see how quickly we can convert this regional cluster. Note that I'm currently in US West 2. This is a single region, to a global database. Basically, now what we're doing is expanding this database to span multiple regions. Just for ease of simplicity, I'm going to just add one region. So here you'll see there's one cluster which has a writer instance and a reader instance. These are Graviton instances. If I select the cluster here and just go to actions, if I do add AWS region, it'll ask me a few different settings where you basically want to just uniquely identify a global database. So I'm just going to put a very simple name. This is global DB. I can choose one of the secondary regions out of many. So you'll see here a lot of regions. Let's select one in maybe Asia Pacific, Sydney. And then you can actually choose your instance configuration, which is where you can mix and match. You can have different instances in your cluster. We'll see that in a little bit later today in today's episode. For now, let's go with the defaults. So we'll stick with the R6G 2XLs. You can scale your reads for increased availability, durability, and fast failovers and other things, but we'll just go with the defaults. There's a lot of tuning. There's a lot of sort of flexible deployment options that you can do here. One thing I'm just going to change is just to make it a little bit easier to read for me and my team. I'm going to call it secondary instance and secondary cluster, just to name it a little bit nicely. But of course, you're free to choose your default names. It doesn't matter. It's going to be a very unique identifier. I'm going to choose everything else as the default. These are all sort of, and also I should point out, the defaults have been a little bit different than the community Postgres or MySQL, right? And these are sort of designed to work really well for a baseline configuration. So the defaults are very intelligent, at least to get you going, get you started. And that's all you do. You start with the defaults. You basically add a region. That's as simple as it gets, right?
What was that, so, 2 minutes, 3 minutes, and you have a multi-region cluster created already? That's amazing.
I have a multi-region cluster. So if I go back here, you'll see that my regional cluster is now sort of getting modified into a global database. And I have my primary in US West 2. I'm going to remove this a little bit. And then my secondary is in Sydney, AP Southeast 2. So we'll give it a few minutes.
So you're actually building a global cluster, right? Like from one end to the other.
Exactly. Awesome. Yep. Exactly.
And how long would this take usually?
Usually, this is all EC2. So this is basically we are provisioning a fresh instance from EC2. We are also sort of provisioning a storage cluster, which is detached from the primary. So we'll go into the architecture a little bit later, but think about this roughly about 6 to 8 minutes, and this should be ready.
Not bad. All right, for a global cluster. And this is regardless of the size, I'm assuming.
This is regardless of the size. Doesn't matter if you have like a small, tiny database or if you have like a massive multi-terabyte database. This timing is going to be consistent.
Yep. Yeah, that's excellent. All right. Well, it seems like creating an Aurora global database is fairly easy. It's and I'm assuming that there's APIs and CLI calls, and that all of this can be essentially just automated and created without even having to interact with like this front end. Of course, you can if you wanted to.
Absolutely. You can use the SDK. You can use the CLI. If you have a preference for a provider like Terraform, you can use Terraform, or you can use our own homegrown CloudFormation. Yes.
Makes sense. Okay. All right. Well, Rohan, now that we have a cluster created, it will be nice to kind of go over like maybe a little bit of architecture, like how this works and what are some of these features, actual real features, right? So Shine kind of touched upon the use cases, but it would be nice to kind of understand what those features are and how our customers can take advantage of it.
Yeah. Let me start by sharing my screen quickly. All right. So, that was a great introduction to global database and, how it some of the key use cases that we offer. But let me just give a quick overview at a very high level. How does it work? And as Shine mentioned, global database is just a feature of Amazon Aurora. And one of the key innovations that Aurora has is that the storage and the compute architecture are disjointed. So what that means is we can scale the storage independently from the compute of your database instance. And global database borrows from the same distributed storage architecture that we've built for Aurora. It replicates data physically from the storage layer asynchronously across multiple regions. What that means is you can have up to 5 secondary regions in your global database. So that means a total of 6 regions for your global, including the primary. And each of the secondary regions can have up to 16 read replicas, which then you can use to scale your read-only workloads closer to your end users across the globe. So in the example that Shine took, we can scale reads in Sydney while our data has been written to in the US North Virginia region.
So if my math's correct, Rohan, this is massive scale, right? Like we're talking about 6 regions, 15 read replicas each. That's like 90 read replicas. That's quite amazing.
You can have quite a bit of read compute. And Aditya, because we're replicating data physically, what we see is that typically the replication lags are less than a second. And I'll show you in my demo, a replication between Virginia and like basically go transatlantic across to EU and see what our replication lag look like. And then you can also see that because we're using dedicated infrastructure, relying on our distributed storage, there is no performance impact on the writer, even at high throughput levels. This is different from some of the other solutions that you'd be used to using on the cloud. For example, logical replication, which has an exponential cliff off when, if the write throughput starts to increase. And then, where the rubber meets the road, one of the key other use cases for global database is the disaster recovery that we've been talking about. It gives you capabilities such as managed failover and switchover that let you promote any of the secondary regions to take full-on read-write capabilities in typically a minute and recover from a true disaster event.
That's fantastic.
But before I go into my demo, I just wanted to cover like two key KPIs that are very relevant to choosing what disaster recovery solution you want. One is the recovery time objective. This is basically the time measured in seconds before your application can resume read-write workload. So if you do perform a DR drill, or if you perform a actual DR in an unfortunate event, this would be measured in the seconds before your application can start writing and reading again. And then the recovery point objective is essentially the time measured in seconds where you could potentially lose data. So these systems are built on asynchronous replication from one region to another. And in case there is a true disaster event and you do perform a DR operation, some of the data may have not replicated from the primary region to the secondary. So we'll look into how does the RPO lag also look like for global database. And you'll see that this typically sits at the lower end of the spectrum where we, because of our physical replication, we can offer better RTO and RPO, and we can have like these mixed configuration that help you balance cost versus your RTO needs. But enough of like talk. Let me actually show you how does switchover work and how you can monitor your global database.
But I do want to call out something important that you said, is the replication, while it's physical, it's still asynchronous, right? So what that means is you're not keeping everything up to date. Like there's no two-phase commit or anything like that. There are no distributed transactions going here. But still, you may lose maybe a few seconds of data, but everything is going to be consistent once you fly over to the other side.
Right. And there's the trade-off between asynchronous and like a two-phase commit is on your write throughput. So this is designed to be fully Postgres, MySQL compatible, and have the highest level of write throughput for your database workloads.
Yeah, makes sense. Okay, all right, let's see some demos.
Yeah, let's jump right into it. So what I have for you is a demo cluster that I've already prepared. And it has a primary cluster in the US East 1 region and a secondary cluster in the EU West 1 region. You can see that the EU West is in Ireland and the US East 1 is Virginia. So we're really going to replicate data across Atlantic. And you can see that the secondary region has two reader instances, as well as, let's look at the endpoints. So these are the way you connect to the instances. There's the writer endpoint, which is inactive because there's no writer. And then there's a reader endpoint that's available for you to connect to the two read replicas that are in this cluster. Let's quickly jump into our Virginia side of the cluster as well. And you can see that there is a cluster inside the global database with a writer and a reader instance. And there are two endpoints, one a writer endpoint to connect to the writer instance and a reader endpoint to connect to the read replica in the same cluster. Let's go back to Dublin. So when it comes to monitoring your database, there are quite a few CloudWatch metrics for Aurora that we publish, including for global database. But if you want, you can also create your custom dashboard. And for the purpose of this demo, I've created a dashboard on CloudWatch. The metrics that I am looking out for this demo are basically the write throughput, CPU utilization, and global DB RPO lag. This is, on this upper side, I have all the metrics for my primary cluster in Virginia. So the blue lines are basically for the cluster, and the orange and the green are for the instances in that cluster. Same thing at the bottom, that's the Ireland cluster. The blue line is for the cluster, and then the two orange and green are for the two read replicas. We also can see that at stable rate, there's basically a CPU utilization for each cluster. And then the RPO lag is essentially the lag in milliseconds. That is the time that it's taking for the data to reach from Virginia to Ireland. And you can see this is 0 milliseconds right now because there's no write throughput or workload that I'm pushing to the database at this point. And when you come to Virginia, you can see that there's no metric defined because there's no replication happening from Virginia to Virginia, right? So it makes this, I'm basically monitoring both and showing you how potentially this would increase. Now let's put some write workload on the database. And so what I have prepared for you is a simple Python script where I'm going to insert into a login table a random login user with some basically timestamp when they logged in and a seed value. Going to commit it on a per second basis in a one single threaded loop. So let's copy the command that I want to use. So I'm going to connect to the writer endpoint in the Virginia cluster. And then I have a shell that I've prepared to connect to the Virginia EC2 instance, which is connected to my database.
Once again.
Okay. So that's the script that I'm going to use, the constant random writes. Let's copy the command, paste the command. And okay, there we can see that the writes are starting to get committed per second. And then there's a random user that I'm just writing to the database. Let's go back to our CloudWatch dashboard and see what happens. So, let's give it some time. And we can see that the CPU utilization has started to increase slightly. The write throughput has started to increase and it's started to settle at around 6.76. When we go down to the RPO lag metrics, we'll see that also the RPO lag is increased from 0 to 313 milliseconds and settled at that value.
Which still not bad. I mean, we're still talking about going across regions, right?
Across regions, across Atlantic and in milliseconds. But now let's see how you can actually do a switchover and rotate the primary region. Because this is a global database operation, you go to the global database level and you go to the Actions tab and click on Switchover Failover. Now, because this is a global database, you could also do it from any other region. It doesn't have to be from Virginia or Dublin. You can actually I'm going to Northern California. I can see my global database and actually go to the Actions tab. This is the North California region. But I can go to the Actions tab and I can still see the switchover failover process. And this is because, what if you have a console outage in Dublin or in Virginia? You can still do the process.
Or region outage. I mean, it makes sense, right? You want to go to a surviving region, then do the switchover
process. So, okay, now let's go back to Dublin. So there are two modes. One is switchover, which is a fully managed process. We take care of making sure data is fully replicated, so there's no data loss. We make sure the topology is maintained. The way it works is we take down the writer instance, make sure data is copied over, then promote a new region and set the replication back. Again, because this is your RTO will depend on how long the process takes to bring the writer, but the RPO would be 0 in this case. Failover is designed for a true disaster situation where a primary.
So just let me make sure. So when we're doing switchover, sorry to cut you off, Ron. When you're doing switchover, the point is there is no data loss, right? That's right. Just to summarize that. But also, both regions have to be up and running.
Right.
Okay.
Right. They're both meant for healthy. Because what we rely on, be able to copy the data over, and we rely on the fact that if the regions are healthy, then we set up all the replication back to the other secondary regions. So you may have 4 secondary regions. We'll make sure the replication pipe is set up and complete the switchover, so you get back to a very working global database topology.
Yeah, and
I'll give you exactly. I was actually going to say, right? So this is actually a very relevant use case where our customers did actually ask for this, right? So primarily around the auditability requirements, right? So financial services, usually what they do is they will have mandates to prove to their auditors that they need to maintain the same levels of commitment and service SLAs, SLOs, RTOs, RPOs in an alternate region. And they need to do these region rotations quarterly or monthly, just to show that the full stack can actually stand up in the secondary region, and once promoted via the switchover process, can actually work and meet those levels of RTOs and RPOs. So that's a very real use case, and that's what switchover is primarily being used for. Yeah.
Right. And apart from that, one other key use case we were starting to see is where customers use switchover to, without data loss, rotate their primary region and do basically a follow the sun approach. For example, you may have trader desks sitting in Australia and USA, and you may want to, in the daytime, have the writer in Australia, so your write throughput is, latency is low. And then when the US trade desk is opening up, then you basically switch over to this region without losing any data, and now your write latency is low for the US region. So we see this two very key use cases for switchover. But as I was mentioning, failover, on the other hand, is is designed to make sure that your region that you're selecting is brought up. It does not wait for it. We try our level best to take down the writes, but in case the region is completely partitioned or unapproachable, we may not be able to do that, right? So this process is designed to just, is asynchronous in the nature. We'll try our best to stop the writes. We'll try our best to copy the data, but in case of like disaster, we'll just move forward after a certain time and start promoting the new primary region. And that's
so I think what you're saying, Rohan, is if you have two regions like this, right, or more than two, if your primary region is down, like hard down, or if you suspect that it's down, then you can use failover. But at the same time, I also want to call out like something like an entire region going down is a very rare event. I want to call that out. Like John Hamilton likes to say, something like that would only happen if a meteor was to come and hit the Earth and then bounce up and then hit again. Those are the type of scenarios, like very unlikely scenarios we're talking about. But then again, it's not out of the realm of possibility.
Absolutely. And that's why we want to make sure that you understand all the connotations. That's why we ask for another confirmation on like allowed data loss, and it is a shared best practice model here. But that said, the complete life cycle of this process is we take down, we try to stop the writes, we promote a new region, and the moment we've promoted the region, you can start your read-write workloads. Now, when the old region that was facing an outage comes back online, the first thing we do is take a snapshot. We basically back up the data so that you can restore in case you want to, you are able to take any data and do some reconciliation. You have that data sitting in a backup. But reconciliation is its own, has a lot of nuances and can be really difficult, especially if your data branched out. So this is why we want to stress, like, this is a very, it can be a disruptive process. It requires some due diligence. And there are quite a few metrics that you can look at before you make this decision. Again, this is a fully managed process. Your global database topology is fully maintained. So moving on, the moment you can, like I said, we ask for your confirmation, but let's go ahead and just do the switchover for now. And I'm going to select the Ireland as my primary and going to confirm. So that starts my switchover process. And what you can see is on the, there's a progress bar that will show you one of the 4 steps and how we are doing against the switchover. You can also start to see that the status of the global database has now changed to show switching over. And then if I just refresh, you'll also see that my secondary cluster has started to get modified. If I go down just to the events tab, so let's, let me select the database first. And let's look at the specific events that we are publishing. So there's more visibility that you get along the switchover process. So you can see it started at 1702, and then let's refresh after waiting for a bit. We can see that it completed in 1704. So just 2 minutes, you were able to get your write capability back after starting a switchover process and have the replication pipe set up to your other region, and have the whole topology maintained. So if we now go back to our EC2 instance, we can see that, I'm not able to execute the query because this is a read-only transaction mode that is the cluster setup. That's because if you go back to the US East region and now I refresh that, you can see it's flipped from a primary to a secondary cluster, and there are only read replicas in this region.
Yeah, the roles have switched essentially.
Yeah, right. And so your write application now cannot write to this region because it's only a read endpoint at that point. At the same time, let's go back to another terminal and let me start the process from the Dublin region. So I have the same application stack in Dublin. And now here I'm going to run the same script again. Let me just copy the command. 1 second. Okay. And run the same process from Dublin. So now we're pumping the same data but now from Dublin. And I just wanted to show you this because I want you to know, let me just see which is the primary cluster. So in the Dublin region now, the EU West 1C is the one that's my writer instance. And so I wanted you to see on the dashboard that now my Dublin region is starting to see an increase in write throughput and the CPU utilization. And what is the key thing that I wanted to point out is you can see how the replication lag for Ireland has now become, not applicable. And for the Virginia region is now starting to become 358 milliseconds, which is now copying data back from Ireland to Virginia now. So hopefully that gives you, the introduction on how we can do switchover and how this is an entirely managed process.
Oh, absolutely. That's very impressive. Yeah, so we were able to switch over, didn't lose any data, and then just start working from the other side like nothing ever happened, right? So that's fantastic. All right, well, we are kind of halfway through the show, so it's probably a very good time to remind folks that please take the survey. We want to know how we're doing. We want to know where we can improve, and there's a bit of incentive in it for you folks. The first 100 people, oh nice, it used to be 50. The first 100 people get $20 in AWS credits, and you can use it in your accounts and have some fun, try out some of the products and see how AWS works for you. All right, so continuing our journey down the global database, we talked about failover, switchover. We kind of talked about how impressive the overall scale is, but let's talk about read scaling, Cheyenne. How does that work? If it actually, usually the replication is based on logical replication, and usually having replication actually impacts the performance of the writer, which is, as I understand, that's really not a problem. But how does that work? And what can you tell about the whole read scaling of Aurora Global Database?
Yeah, absolutely. And I think quite an incentive there to actually try out, right? So folks, please do take that opportunity and sign up. I think it's a great way to kind of get free credits and try it out yourself. So and I think Rowan did an awesome job. I love the Falcon in the terminal. I think that's a really nice touch. So let's get into read scaling, which is the other sort of use case that we talked about. And why do we actually care about it is, again, like we discussed, global businesses growing international, expanding their footprint globally, going cross-Atlantic, like a lot of sort of avenues of expansion, right? So what customers typically expect in such businesses is they don't want to wait forever to run their transactions. Let's say if you're on Amazon, you're trying to buy something. You don't want to wait forever for your transaction to go through. If you're a Prime member, you want it to be like immediately, which is what I do. I'll add that to my cart. I'll add a product. I'll check out. I get done very easily. And that's the sort of user experience. But in the backend, there's a lot going on, right? So there's this consideration around logical versus physical replication. There are storage architectures which are fundamentally different. There is compute involved. There's a lot of microservices internally, which is making it such a smooth experience for our users. So with global database, what we do, like we saw in the architecture that Rohan brought up, the fundamental thing that is different is there's a decoupled compute and storage. Now that's within a region, but also when we are expanding globally, there is a different sort of compute and different sort of storage architectures. that we provision with global database. And the way this works under the hood is we are using dedicated infrastructure for a physical storage-based asynchronous replication, so which is very quick. It's using the AWS backbone network, which helps us get to that sub-second sort of latencies. And you've seen how we were below even 500 milliseconds in most cases, right? So in order to expand the sort of global footprint, and then you start looking at like read scaling, what I'll do is I'll quickly show and tell this story again. So let me bring up my screen and show you what I have going up. Yep. So, and folks, if you have questions, as always, please feel free to throw them in the chat. We have a team who's going to answer them for you. So let's look at a realistic setup here, right? So I'm in production. I am looking at expanding my global footprint in 2 different regions. So this is sort of my cluster. This is my global cluster with my primary in US West 2, which is Oregon. And I have a couple of different regions for different users, right? So if you see here, I have my global cluster. I have 3 regions in this. So my primary is my US West 2 with 2 instances, 1 writer and 1 reader. I have my secondary, one of the secondaries in Northern Virginia, which is US East 1. And this is where we actually give you, as customers, we give you the flexibility to mix and match, right? So essentially, you'll notice that there's a different instance here. There's a different instance here. There's actually serverless going on here.
Yeah, and I want to say, like, this is peak Aurora right here, right? Like, where you essentially get the flexibility, and you use what you need, and then you pay only for what you use, right? That's kind of the motto of Aurora.
Exactly.
So that's fantastic.
Exactly. So in fact, AP Southeast 1 or 2, in this case, Sydney, is where I'm seeing a little bit of like light activity. It's still not there yet. It's still not production ready. But this is where I still want my database to be up and running. I want my data to be copied over. I want a DR posture there. But my compute doesn't have to be up and running all the time. So essentially whenever I want those queries to run, it'll run, and then it'll just spin down to the minimum capacity. And I don't have to pay as much, right? So that's the use case. And what I'm going to do here is actually run a few different tests. So this is what I'm going to do. I have my primary region, which is typical of a production. What you'll do there is moderate mix of read and write. So there's a script that I'll run. I'm going to use PG Bench, which is a very popular open source Postgres-specific benchmarking tool just to see your latencies, average and standard deviation around latencies. So I'm going to run a whole bunch of things against the primary. I'm going to run a whole bunch of heavy read workloads against the secondary. And if you notice here, the dense compute is actually our newer offering. It's less than a year old. This is for optimized reads, which is where you actually leverage it for a lot of heavy either analytic queries, or you can use it for reporting queries, or something like GenAI, right, which we have been seeing quite a lot in the past few episodes.
I was wondering when you were going to say GenAI, Cheyenne.
Yeah.
cannot.
It's complete without that plug for him.
It's not complete. I cannot finish this without GenAI. I'm sorry. Fun fact, if you can count the number of times I say GenAI by the end of this, please throw that in the chat. Let's see who gets it right.
Twice already, too. I'm counting.
And the third one is actually the sporadic workload, right? So I'm not expecting a huge read query there. Maybe someone comes in, reads something, and then just they're gone. So this mix of sort of query patterns is what I'm seeing. And then if I bring up my terminal here, so this is my terminal. I have a 3-way split screen. So what you'll see is this vertical sort of window is my primary region. This is Oregon. On the right, on the top, is my Northern Virginia, one of the secondaries where I'm running my heavy read query. And on the bottom right is my Sydney, which is my serverless. This is my sporadic read-only workload. Now, if I go here just to look at like what I'm dealing with, I'm actually looking at like these 4 dummy tables that PG Bench will create whenever you're running these benchmarks. And if I try to look at like the number of rows just to get a sense of the magnitude, we're looking at like 10 million and higher, right? So we are looking at greater than 10 million rows, which is typical of like a production use case. Now, what I'm going to do is kick off 3 different scripts. This is my read-write test. This is my read-only here for the first one, which is a heavy read. So if I go back to the query itself, you'll notice that this is the read-write is doing an insert followed by a few different selects. These are point selects where there's a little bit of min-max analytic query happening. There's a little bit of average here. The second one is actually doing a lot more, which is where I'm doing a massive join amongst all the tables. And then I'm also doing an average on these sort of million row tables, 10 million and higher. I'm just randomizing these numbers, multiplying that by 1,000, which is my scale factor, etc. And then the third one is mostly I'm spending time sleeping because that's representative of like serverless, where I'm just randomly sleeping between 1 to 5 seconds. But when I wake up, I'll do a little like a small query, just a point select query here.
Sorry, I thought you were talking about me. Never mind.
All right, so let's get these tests going. I'm going to kick it off. And you'll see just a little bit of a matrix show going on here with a whole
Yeah, that's what I was thinking.
gibberish. There we go. Is it GenAI? Is it not GenAI? What is this?
I'm counting, man. This is 4 times already.
So while that is happening, let's actually look at like what's going on, right? So we can, again, I have a little bit of a different dashboard. So I can build my own dashboard. I can customize this very nicely the way I want to look at this. You'll see a little bit of my global DB RPO lag sort of, I've sort of averaged this. I've been running this, of course, since the morning, since hoping that the demo gods will be with me. So if I reduce the granularity, this is 1 hour, this is getting refreshed. You'll see this is consistently less than 1 second, right? This is my average global DB RPO. I want as much data on my buffer cache as possible. So my buffer cache hit ratio is close to 100%, which is awesome. And then I have my global DB RPO lag sort of always less than, this is getting averaged every second. But then if you look at this, which is the realistic over the last sort of couple of hours, this is the average RPO lag.
So real time, we're still in double-digit milliseconds, but over the time, it's still under a second.
Exactly. Exactly right.
And these are really far off. Like we are going from Virginia to Sydney, and
Exactly.
I think you had another one in the mix. So, it's averaging out across 3 very far spread continents.
Exactly. And this is actually also very easy to create. So if you want to create something like this on your CloudWatch dashboard, what I'll do is turn on autosave because I'm lazy. I'll go here. I'll select number. You'll see here you can create a lot of things across the stack, but what I'm interested in RDS. And within RDS, I'm interested in the global DB RPO lag for my secondary, one of my secondary regions. And let's just go with secondary in Northern Virginia. So this is my secondary, Northern Virginia. Yeah, so I'll select this. And if I go to graph metrics, what I can do here is an average, a minimum, a maximum, P99s, P95s. I can select a lot of these custom metrics, but let's go with the average. And then I can do it every second. I can do it every minute. I can do 5 seconds. Let's go with 1 second for now. Create this widget. And this is what you're seeing. So basically you can resize, you can just customize these dashboards the way you want to look at it. And it'll save it for you. It'll refresh this automatically every 10 seconds or whatever you wish to choose to. And it gets very easy to actually track these things, right? So if I go back now, you'll see of course, my transactions have finished. I ran it for a couple of minutes. If you see the read latency here, that's the number we are interested in. The average latency for my moderate workload, which is hitting my primary, is actually 7 milliseconds. And you'll see pointed statement, like per statement latencies as well. So my inserts, my writes were 2 seconds. My selects were 1 millisecond and 2 milliseconds. These are all in milliseconds.
The seconds.
And then on my top right, which is my heavy analytic query, you'll see this is the most it took was about average 2.2 for this statement. And the average was about, again, 2.2 seconds. This is a massive heavy analytic query, mind you. And then on the serverless side, we are looking at like less than 2. This is like 2 milliseconds for that point query. Of course, I'm spending like between 1 to 5 seconds sleeping. So PG sleep will actually shut down the cluster. It'll just go into hibernate mode. And then when it wakes up, you basically see that again finishing at like sub-millisecond range, right? So this is basically the latencies that we are interested in seeing on the customer side. If you're on the e-commerce side, or if you're in a travel website, try to book your tickets, try to sort of get to that vacation in Hawaii, this is what you want as a user, right? So
Cheyenne, you need to get that Hawaii vacation, man. You kind of mention it on every demo you do.
it's my favorite destination. I cannot say it enough. I
All
wish.
right, well, that's fantastic.
I wish the company comes sometimes send me there.
Well, we'll make a case for you. All right, well, that's great. Let's see. So a Moon 8 Birdie wants to know, does high read workload on the secondary regions impact the overall replication lag? I'm guessing that's a no, but I'll let the experts answer.
That's a no. The replication, you can pump basically whatever throughput on the readers. It's managed through the dedicated replication infrastructure, so the lag will not increase because the impact is not getting transmitted back to the replication infrastructure. But it is possible that your read replicas start falling behind because they are not able to get the data from the replication agents as fast as possible, right? So the impact is isolated to your read replicas, but not to the replication pipeline itself. So your RPO does not increase, which is your the amount of data loss, but your read replicas can have impact because there is a physical limit how much you can push the read replicas, right, in terms of CPU and the network bandwidth and things of that nature.
That makes sense. Well, all right. So we are kind of drawing to a close, but we still have one use case remaining. So we covered our DR drills, we covered read scaling, we covered follow the moon, no, follow the sun type of workloads. Now, of course, there are some use cases where customers want to still write from the secondary region, even if you have read replicas only. Do we have some sort of a trick up our sleeve to help with those use cases?
Yeah. So let me just talk about this functionality that we offer called write forwarding, which is part of both Global Database and Amazon Aurora within a region. So for both Postgres, MySQL, we offer both like a local write forwarding and a global write forwarding functionality where you can essentially, the use cases, like as Atif was mentioning, some applications, though you've built them to be running read-only in these faraway regions, may want to record some kind of data at time to time, right? For example, you may be wanting to update a metadata table after some authorization processes have taken in the application, right? To just record just the state of affairs. And so for these writes, the complexity involved is you have to go across a region because there's only one writer in this highly consistent Aurora global database. You have to make a cross-region write somehow. And so that complexity is solved by write forwarding. So let me just show you very quickly what does it look like. So I have my demo cluster set up again. We're back to the same guy here, the demo global database. And what write forwarding essentially does for you is, well, let me first show you how you can actually enable write forwarding. So write forwarding is enabled on a per cluster basis. So if you have multiple secondary regions, you can actually go to individual clusters and modify and say, I want write forwarding to be available from this cluster to the writer instance. And the way to do that would be if you just go to the cluster and hit modify. It looks very similar to the create page that Cheyenne showed earlier in the demo. But if you go down, there are these two options, as I was mentioning, known as local write forwarding and global write forwarding. The local write forwarding is from the in-region read replicas to the writer. So this is more applicable for the primary region only, but we can turn it on in all the regions. And then when it's a primary, you can use it. And then the global write forwarding is essentially for doing cross-region writes. So I've already set this up. I've already got it turned on. It doesn't require a restart on your database. It's not a modify process. But let's go. The key parameter, the key thing about using write forwarding is it allows you to essentially submit your writes to a read replica. And the magic there is that we understand when in a write operation, when in a query, there is a write operation along with the read operation, we take the writes and forward them to the writer. So we've taken care of all your networking aspects. You don't have to set things up from networking perspective to send this write across regions. You don't have to worry about like connecting to different endpoints. And then I'll cover consistency also between read and writes in a bit. But I just want to show you something more basic to begin with. How does it actually work? Can we actually send a write from across a region? So I'll go back to my, I just want to show you the reader endpoint for this cluster is, let's just copy this, the RO read endpoint. And then let me go back to my EC2 instance and connect to the Dublin region. Okay, let's connect to the database. So I'm using the read-only endpoint for the EU West 1 region. That's my Dublin cluster. All right, I'm connected. Let's just, do a select star on the table that I've been writing to. This is the logins table. Oops. Sorry about the typo. Oh. All right. So we can see that there is there are some random names in the table, but just recording the last UID. So now let's write to this table from the Dublin region, right? So I'm going to just insert a value into this table, and there you go. It's just forwarded to the region. Let's do the select star again, and then you can see that was written and has replicated back in the time we were submitting the commands. And so, this is the power of write forwarding. It's taken up a lot of the heavy lifting for you. But there's still one use case left when it comes to write forwarding. That's very difficult to build in the application. So if you have cases where you have a write and then immediately you have a read, and you need some kind of consistency between the write and the read. Now, I'd like to remind you, this is an asynchronous replication. So if you're writing from the Dublin region, it would still take 300 milliseconds for the write to propagate back to Dublin, as we saw in the earlier demo. But if your application needs that read right away, and for like a subsequent set of calculations or things in your logic in your application, you have to build some logic that waits for 300 milliseconds, and that lag is very dynamic. So we take care of that problem as well. And let me show you how. So let me go back to my cluster. There is a parameter group that you can configure for consistency of write forwarding. So let me go to my parameter groups. I've already set up a custom parameter group for this because that's the way you apply. There's a default parameter group, and then you can create a custom parameter group if you want to modify certain settings. And so the main thing about the write forwarding is this APG and equivalent in AMS write forwarding consistency mode. What that tells us is, let me actually go and modify this. Okay, so if you look at these values, there are basically four values that you can use from: eventual, session, and global. What that means is, if you have in your query some kind of write transaction followed by read, and you set this mode to eventual, we will not wait for the read queries to give you any sort of consistency. So you write and you read, your read may not see the latest write that was submitted from the Dublin region. But if you choose session, what will end up happening is, for the connection that you open from your application to the Dublin read replicas, and any write that you submitted, the subsequent read would actually wait for that write to come back. So you don't have to build any complex logic in your application to wait for this write to get propagated back. And then the global is even a step beyond. It actually not only waits for that connection, but all connections across the read replicas to make sure whatever writes were actually committed, all of those writes from different connections are propagated back before serving you the next read. We typically see session from an application logic perspective. The session consistency mode is generally what customers are looking to use. because, as you want more consistency, the trade-off is that your latency would increase because there's a lot more waiting happening for your reads and writes in these other regions. So I just want to go ahead, Nathan.
I was just going to say the famous or infamous, based on how you look at it, read after write consistency strikes.
Yes.
There are a lot of customers who just want to make sure that I need to be able to write or read what I just wrote. And as you start developing these cross-region applications, some of these things start to get more interesting.
Right.
But I know we have solved this problem in global database a long time ago, and it's actually now also ported to the regional reads.
It's also
which is what you were showing just a minute ago.
Yeah.
So
and you don't have to take care of like splitting your read and writes in your application. We do that for you. So let me very quickly show that aspect as well and show how the eventual and session consistency mode might look differently. It should just take me a minute or two. So I have the same Python script, but the difference here now is that I'm inserting into the table, committing, and then right after that, I'm reading by just having some sleep in the middle and then reading the top 5 rows. And then I'm running this over one thread. We can also do multiple threads and see the same result. But for now, I'm going to stick to one thread and show you the demo. So let me just go back to my terminal. I already have Postgres connected. One of the things you can do is just very quickly, we will check the consistency mode. So the command to use would be, there's a variable that gets set for your cluster, which would be the show APG write forwarding consistency mode, should be set to, let me copy that again. Okay, so it is already eventual, right? Let me run my script. Okay, let me run my script quickly. So this is the demo script that I've prepared. I'm going to run this. I'm not connected to Dublin. CD. Stress. Let me clear the shell. And so what you can see is I wrote this random username, Tiffy IV, and then essentially I didn't see that replicate back, right? These are ordered in the ID the way I have kind of entered it. So because I read very quickly within below 300 milliseconds, I did not essentially see that write propagate back. But if we switch to session consistency mode, so let's just have this change to session.
Okay, so that's a dynamic change. That's great.
It's a dynamic change. No need to restart. Let's connect back to the pSQL. Let's make sure it's propagated. Boom, it's connected and it's propagated back. Let me clear the screen again and run the same test. Oops, not this one. I'm way more fidgety than Cheyenne is. He's had lots and lots of practice. So you can see now I entered this random user VIV or WIWIXU, and magically now we have that propagated back and waited for my next read. So you can see that it's consistent. It's waited for the write to propagate and shows you in the session consistency mode. So hopefully that gives you flavor of all the things that we've built into write forwarding and into the smartness that we've built into the engine for this feature. Back
Absolutely.
to you.
Excellent. Well, we are at time, or almost time. We just have one more minute left. So I'll add another plug for our take our survey. Please, you should see that survey link. There it is. To let us know how we did. Let us know our feedback, and if there are any more of those credits left, go and grab them. Again, thank you all for tuning in. Thank you so much, Cheyenne and Rohan, for your expertise. We do this show every other Thursday, and we'll continue to make this show going into next year. So come check us out again and learn more about relational databases on AWS. Again, thank you so much all for attending. Thank you for our staff for taking care of all the questions, and we'll see you next time.
Thank you all. Take care.